Let us have a look at the Rymax products. We took the Endurox LD 15W40 as an example. You will find quite a lot of information on the labels of this product. We will discuss the main key characteristics of this product to make you better understand the difference between this product and another product. First of all, view the number written big and bold, 15W40. 15W40 is the viscosity of the product. But what does this mean? The viscosity of the product? The viscosity is a measurement of resistance to flow at one temperature. As example, water has a very low viscosity, and honey has a high viscosity. The same goes for oil. Some oils are rather thin, and some oils are thicker. The lower the numbers, the lower the viscosity. So a viscosity of 10 is lower than a viscosity of 50, which means the viscosity of 10 is thinner. For engine oils, the viscosity is classified by the Society of Automotive Engineers, SAE. Therefore, you see often SAE written in front of the viscosity numbers, like SAE 50 or SAE 5W40. SAE makes a difference between monograde and multigrade oil grades. Monograde oil can be recognized by the fact that there is only one number, like SAE 50. Multigrade oils can easily be recognized by the two values on either side of the W in the viscosity classification, like SAE 5W40. The W stands for winter. The number on the left side of the W in the viscosity classification informs you about the winter or cold property characteristics of this product, which means it indicates how well the product flows when the engine is cold and not at operating temperature yet. The number on the right side of the W informs you about the summer property characteristics of this product, which means it indicates how well the product flows under hot circumstances when the engine is at operating temperature. The bigger the gap between the value before the W and behind the W, the less the oil loses performance under the influence of the temperature. So a product with a viscosity of 5W50 better responds to temperature fluctuations than a 10W30. Until about 15 years ago, it didn't matter very much which oil you used in your car. Often it was a 15W40 or 10W40, and this oil lubricated excellent. Due to increasing attention for the environment, car manufacturers are also looking for possibilities to save fuel. One of those ways is to use a thinner oil, even though the primary purpose of oil is to lubricate the engine parts. The advantage of a thinner oil is that it generates less resistance so that the engine can run more efficiently. A logical consequence of this is that the engine uses less fuel and emits less CO2 emissions, something that the car manufacturers focus on. Over time, engine oil has become increasingly thinner, from 15W40 and 10W40 to 5W40 and 5W30. And these days you see products like 0W20, 0W12, and even 0W8, products thin like water. Trucks use thicker oils than cars, because thicker oils give more protection for more severe operations. Also, when the conditions are getting harder, it is wise to choose for a higher viscous product, such as driving through mountains, pulling a boat, dusty conditions, heavy loads, etc. Finding the optimal viscosity is finding a balance between engine protection and minimizing wear. You want the oil to be of lower viscosity to support efficiency and improve fuel economy by decreasing engine friction, but also give good protection at a cold start of the engine, since the thinner oils flows quicker through the whole engine than a thicker oil. But you want your oil as thick as possible to give protection in more severe operations. Therefore, you will see that trucks and other heavy-duty machinery are using normally thicker oils than cars, because thicker oils give more protection for more severe operations. Also, when the conditions are getting harder, it is wise to choose for a higher viscous product. The best viscosity depends on the type of machinery, on driving behavior, and external conditions. For industrial oils, you will see that these are not classified by SAE, but by ISO, like ISO 46 or ISO 320. For industrial oils, you see in general monograde products, since these products don't face similar temperature fluctuations as in engines or gearboxes.